Welcome to my channel Academy of Computer Science. Today I am discussing about Coal India Limited Management Training Exam. The trade of this exam, Computer Science and IT. Now this trade is under system. So before starting, now I am discussing Academy of Computer Science provides semester coaching for B.Tech CSE and IT and Diploma CST, BCA.B.SC. So there are total 10 sections in the Management Training Exam of Computer Science and IT. So your first section is digital logic. In the first section digital logic there are total 5 portions. First is Boolean algebra, second is combinational and sequential circuit, and third is number representation, fourth minimization, and fifth arithmetic. So at first I am discussing the Boolean algebra. You must have to know the different laws of Boolean algebra. At first, distributive law. Distributive law, A plus C is equal to A plus B into A plus C, and another A into B plus C is equal to A into B plus A into C. This law is very important for the minimization purpose. This law. This is the distributive law. There is commutative law. Different law you have to know. Commutative A plus B is equal to B plus A, and A into B is equal to B into A. And another is associative law. A plus B plus C is equal to A plus B plus C, and same for multiplication. A into B into C is equal to A into B into C. Okay, and another complementary law. Complementary law. In complementary law, A plus A bar is equal to 1 and A into A bar is equal to 0. This law is very important for the minimization purpose also, because if you find any example and there is any expression 1 plus something is equal to the result will be 1. So in your question, if an equation for simplification is given, then if the option is 1, then more chance that answer will be 1. So another law is De Morgan's theorem. Is you must have to know De Morgan's theorem law. De Morgan's theorem. In De Morgan's theorem, A plus B complement is equal to A complement into B complement, and another A into B complement is equal to A complement plus B complement, and another is principle of duality. Duality states that 1 is represented to 0 and 0 is represented to 1, and there is no change of their complement, and is converted to OR and OR is converted to AND. And in the Boolean algebra, this is the only basic law, and you must have to know the different gate. Different gate, AND gate, OR gate, NOT gate. There are 3 type of gates. Basic gate. In basic gate there are 3 portions: AND gate, OR or NOT. This NOT gate is called inverter. Inverter. Why it is inverter? A or A bar, if it is 0 it will be 1, and it is 1 it will be 0. So this is called inverter. This is the NOT gate, A bar. And AND gate there is minimum 2 input, and OR gate there is also minimum 2 input. These 3 gates are called basic gate, because from these 3 gates we can construct any circuit. For that reason these gates are called basic gate. And next, universal gate. Why it is called universal? In universal gate, NAND and NOT gate, NAND gate and NOT gate, NAND gate and NOT gate are called universal gate, because from these 2 gates we can convert any gates. It may be either basic, it may be exclusive or exclusive NOR also. And there number 3, exclusive XOR gate and XNOR gate. This is XOR gate and this is XNOR gate. The output of XOR gate A XOR B and A XNOR B. Okay. So later I am discussing the different gate output. Okay. So suppose this is two gates A and B, 0 0 0 1 1 0 1 1. If it is AND gate, this is the symbol of AND gate, so result will be 0 0 0 0 1. The question is that in AND gate, if there both the inputs are 1, then only output will be 1. In this table we can also told that, but we can also said that if the inputs are high, all the inputs are high AND gate, then only the output will be high. Otherwise all the output will be low or 0. In the OR gate, this is the logic of the OR gate or circuit diagram, 0 1 1 1. If any input is 1 or any input is high, then the output will be 1 or output will be high. Okay. Next, NAND gate. NAND not of AND. This is the NAND gate. The bubble is the symbol of the NOT. Okay, NAND means not of AND. So it will be 0, the reverse of AND, 0 1 1 1 0. And also for same as for NOR, also opposite of OR, circuit will be this and this in one bubble. This is will be 1 0 0 0. Another is XOR gate. In the XOR gate there is also, okay, so 0 1 1 0. In the XOR gate, if the inputs number of 1 in the inputs are odd, then only output will be 1. In this 0 1 and in this input 0 1 1 0, the total number of 1 is 1, so it is odd number. So for that reason XOR gate output will be 1. And another for XNOR gate, bubble of XOR or not of XOR, this circuit opposite of XOR 1 0 0 1. Okay. So NAND gate and NOR gate are called universal gate, AND gate, OR gate, and also NOT gate is called basic gate, and XOR and XOR are universal gate. So you have to know also the gate conversion from NAND gate to either AND gate or OR gate or XOR gate or XNOR gate. So let's start for any one conversation. Now I am studying NAND to XOR gate conversion, NAND gate to XOR gate. If you follow this example, then you can convert any gate. So at first you must have know to the XOR gate output A bar B plus A B bar. But in the NAND gate, it can't accept any OR or plus symbol. It always accept AND. So now we will convert this expression into AND format. So how will we convert plus to into or to AND? We have already known the De Morgan's theorem. It is the only principle of De Morgan's theorem that it convert the plus into multiplication and multiplication into plus. So at first A bar B plus A B bar. Okay. These and these are same because 1 double bar is equal to 1. So this is the under law of involution law. So at first we will differentiate A bar B into bar into A B complement this complement. This is known as A complement or A bar. Okay. Now we have decomposition the formula into AND format. Now we can easily draw the XOR gates our input using NAND gate. This is A, this is B. A bar with the help of, I have already told you that NAND gate and NOT gate don't accept single input. So it is double input, A and A are same. This is called idempotent law. A into A is A and A plus A is A, it is under idempotent law, idempotent law. So A bar, B bar, A bar or A complement B, A complement B complement and A B complement. Okay, this will be A complement B into A B complement B complement. Okay, this is the answer. So these are under Boolean algebra, etc. And now I am discussing combinational and sequential circuit. In combinational circuit there are mainly 4 combinational circuit. Number 1 decoder, number 2 encoder, number 3 multiplexer, this is called mux, and another is demux. In decoder there is n number of input and produce 2 to the power n output, input 2 to the power n, input n and output 2 to the power n. So example, if it is 2 then output will be 4, if it is 3 output will be 8, if it is 4 then output will be 16. If the input is 2 output will be 4, if the input is 3 output will be 8, if the input is 4 output will be 16. You have know the application of decoder, you must have to know the application of decoder, encoder, multiplexer and demultiplexer very well. In the encoder there is opposite of decoder, it accepts 2 to the power n number of input and produce n output. So if you supply 8 input then output will be 3, if you supply 4 input output will be 2, if you supply 16 input then output will be 4. This is the example of encoder. In the mux, 2 to the power n into 1, you provide any number of input, try to provide power of 2 input and produce only one output. This n is the select line. So if you supply 4 input output 1, 8 input output 1, 16 input always output 1. But if 4 2 to the power 2 is the select line, 8 means 2 to the power 3, so 3 is the select line, 16 2 to the power 4 is the select line. But in the demultiplexer it accepts only one input and produce 2 to the power n output, and here n is the select line also. Okay, so this is the combinational circuit. And another is sequential circuit. Why it is sequential? In the sequential circuit always clock is used. What is the, you must have to know the difference between latch and clock, latch and flip flop. With latch with help of clock is called flip flop. So there are sequential circuit, there are flip flop, register and counter. Flip flop, register, counter. In flip flop there are SR flip flop, set reset flip flop, JK Joule Kilby flip flop, and T flip flop, toggle flip flop, D means delay flip flop. You must have to know the different characteristic equation, different characteristic table and the excitation table of the SR flip flop. So I will try to provide another video for details of the flip flop. Now I am discussing shortly in the flip flop. So this is the latch, this is the latch. If latch, suppose this is NAND latch, okay. If latch, this portion is called latch, this called is latch. If latch with clock pulse is called flip flop, clock pulse is called, now it is flip flop. It may be JK flip flop, it may be SR flip flop, it may be T flip flop, it may be D flip flop. In the SR flip flop, the excitation table by characteristic equation or characteristic equation, the characteristic equation of SR flip flop is that QT plus 1 is equal to S plus R bar QT. Okay, mind it carefully. In JK, QT plus 1 is equal to J into QT bar plus K bar into QT. Into T flip flop, QT plus 1 is